In the second video for business calculus, we're still dealing with the pre-calculus kind of things, but we're going to look at the algebra of functions. If you are looking at this, you see three functions there. The p of x is equal to r of x minus c of x. So can we really do this? Basically what this is saying is you have one function and it's equal to a second function and you subtract a third function from it. So as you might be inclined to think is that yes, it is possible, and it probably becomes more clear if we say that p of x was the profit function, or the profit for the company, and that equals, as profit always does, the revenue minus the cost. So you'd have a revenue function, subtract out the cost function, and you end up with the profit function. In real simple ways, if we start with this function, f of x is 2x minus 3, and g of x is 4x plus 5. If we want to add these together, it is as simple as you might imagine. You take f of x and add g of x to it. So f of x is 2x minus 3, and then you simply add g of x, the 4x plus 5. So now you just simply combine common terms, add all the x's together and all the constants or all the values together that are without any x value or x associated with it. And of course we get 6x plus 2. So this is what f of x plus g of x is equal to. And it's kind of the same thing for subtraction. If f of x minus g of x is going to be 2x minus 3 minus the second function. Now when we're doing this, it is really good if we remember to use the parenthesis on this. It helps us to remember that since we have a minus sign, that this gets applied to whatever is inside. One common student mistake is to write it down as 2x minus 3x and then to say minus 4x, but then not apply the negative to the plus 5 and leave it as plus 5. Hopefully this just makes it a little bit clearer that when you do this, you're going to end up with minus 4x minus 5 when you're done with it, and then when you apply the negative, and when you add these together, 2x minus 4x is negative 2x, negative 3 plus a minus 5, or negative 3 minus 5 is minus 8. And we can do the same with multiplication. It looks like this, just f of x, g of x. You don't have to write the little multiplication sign in between. When you see this, that's just what it means, multiply. So you take f of x and you multiply it together with g of x. Now when you do this, there are different ways that you can do this. I'm going to introduce the FOIL method. You can just use the regular distributive method for multiplying, it works fine. The FOIL method uses something that becomes a little bit easier when we're going to go backwards. When we have a function, say x squared plus 2x minus 1, it gives us a way to work backwards so that we can factor out and find what the two parentheses are to each other. You'll see more of that when you get to it a little bit later in the course, or a little bit later this lesson. But the FOIL method uses these letters that when you're multiplying this out, you first do multiply the first terms inside of each parenthesis, hence the F for the firsts of each parenthesis. So that's going to be 8x squared. And then you do the outer two. And you look at this as 4 in a row. You do the first one and the last one, the outer 2. And of course that's going to give you 10x. Then you do the inner 2, which is basically the second and third term if you think about it, but the ones in the middle. And of course that's negative 12x. And then you do the last terms. The minus 5 times plus 5 gives you a minus 15. And if you put those letters together, of course, it's the FOIL method, F-O-I-L, first, outer, inner, last. You don't have to do it this way, but it's just a way to do this that later makes it easier to factor things. And of course, we have to combine common terms, the plus 10x minus 12x gives us negative 2x. And of course the answer is as is shown. Here are 4 problems that you can work through. We can work through the first one together to become more comfortable with the FOIL method. When we do this, we're going to multiply the first ones together. So that's going to be the x and the, let me grab my pointer here. That's going to be the x multiplied by the x. So of course that's going to be x squared. Then you do the outer, so that's going to be this term, the x, multiplied by this term, and we get the 4x. Then we multiply the inner terms, which is going to be this x and this 1, so we get 1x. And then, of course, the final is to do the last in each parenthesis, so we get to 4 times the 1, and we get 4. Combine like terms, we get x squared plus 5x plus 4. If you want to work through the rest of this, you can pause the video here to do the other 3, or at least the next one. I'm going to introduce something else between the second and third one, but you can pause the video now, and I'll restart again very shortly. I'll restart in 5, 4, 3, 2, 1. Now, the second equation, or the second problem here, if we multiply the first, we get x squared. And if we multiply the outer, we're going to get minus 4x. We multiply the inner, it's going to be the negative 1 times x, so that's going to give us negative 1x. And the minus 4 times the minus 1 is going to give us positive 4. You'll notice that all of these are basically the same, it's just that or the same x and constants, but I changed the signs in between. We should always get a different answer because of this, and we do. When we combine the common terms of this negative 4x minus 1x, we get, of course, minus 5x. So we end up with x squared minus 5x plus 4. Now, if we look at these first 2 problems, we realize what's actually happening here is that when we have x plus some number, let's just call it c to mean any number that could be there, times x plus d, again, some other constant, some other number, we're always going to get an x squared plus, and then if we look, we notice that the middle term is always c plus d. So we look at the c is here and the d is here. In the first one, the c was plus 1 and plus the d was plus 4. Add them together and you get 5x. You put the x afterwards, as it shows here. And the last term is simply c times d. So this c times d. In this problem, it's again 1 times 4, so it's plus 4. So that works with this. It's kind of a shortcut, and it is what we're going to, it still helps in the factoring. You can save some time when you're doing this. You can actually look at this, and again, you can do first the first 2, you can do the outer, you can do the inner, and then you can do the last, or you can say, it's x plus 1 times x minus 4. There's no numbers in front of the x's, so it's going to be x squared. And take c plus d. 1 minus 4 is going to be minus 3. And then, of course, you put the x after it. And then plus c times d. Positive 1 times negative 4 is minus 4. So when we do this, we see this kind of thing happening. It is x squared, as it's just going to be that way when there's no numbers in front of the x's. You add the coefficients, or the c and d together, and that becomes the coefficient. And then you multiply c times d, and you end up with x squared minus 3x minus 4. So if you want to do that on the last one, you can pause it again to practice it, and we'll go over it. I'll restart again in 5, 4, 3, 2, 1. Now, this last one, if we do the same thing, we have x squared, and we're going to take the minus 1 and plus 4, so that's going to give us positive 3, and of course we write the x after it. Negative 1 times positive 4 is negative 4, so that becomes our answer. So you see this formula can save a little bit of time. As long as you're understanding what it is you're doing, eventually what we're going to do is to take this x squared plus 3x minus 4 and do it in reverse to get this x minus 1 times x plus 4. So as you see, if we just have the number here, you realize that this is the concept. When you add them together with the x, and when you multiply them together, you get the 4. So then you would just come up with two numbers that will do that and work in this form when you work backwards. But we'll mention that briefly. Continuing with the algebra function, can we divide functions? Well, yes, of course we can. F of x divided by g of x. In this case, using our same f of x and g of x as before, we would get 2x minus 3 divided by 4x plus 5. Now, when we're doing this, we have to realize now we've turned this into a fraction, and the denominator, the bottom of the fraction, can never be equal to 0. So we always need to keep this in mind. And usually when we do division, then we also annotate that x cannot equal some number. Well, of course, with this, the denominator can never be equal to 0. So you take the entire denominator, set it equal to 0, and then solve for x. Subtracting 5 from both sides gives us this, and then divide by 4. So we know that x cannot equal negative 5 over 4. And it is good math practice to do this, but it also becomes practical, we'll see very shortly, to list all of the values that x cannot equal to, because when you're working with more complex equations, one of them can get lost, so to speak. And if you don't show it, then you won't know that the function doesn't actually exist at that point. An example of what I was just talking about is this function. We have g of x is equal to this fraction x divided by x minus 3, and h of x is equal to x plus 1 divided by x minus 5. What is g of x minus h of x, or divided by h of x? Well, we can simply list them all. G of x divided by h of x is this. Now, at this point, it's really good to list the values that x cannot be. And we realize that there are several values here, because since this is a fraction, this x minus 3, that can never equal 0. And this can never equal 0 as well, because h of x has the denominator x minus 5. X cannot equal 5. G of x cannot equal 3, of course. When we look at that, we see that here, and so those values need to be listed. However, there is another value that x cannot equal. When we're doing this, if h is 0, or if the numerator of h of x is 0, if x is negative 1, then you get 0 for all of h of x, 0 over some number. Well, I guess it would be 0 over negative 6, which is 0. But then you would replace 0 here and say, oh, well, it's g of x divided by 0, and that can't be. So when we're doing this, we have to go in and say, okay, x cannot equal 3 values. And again, we had said x cannot equal negative 1 because of the numerator here of h of x. It can't equal 3 because of the denominator of g of x, and it can't equal 5 because of the denominator of h of x. Listing that's important because when we solve this problem, whenever we have a fraction divided by a fraction, of course we invert the denominator and multiply. So we're going to take the x divided by x minus 3 and multiply it by, invert this fraction, flip it over. 5 minus x over x plus 1. Now, when we multiply this out, we end up getting x squared minus 5x over this x squared minus 2x minus 3. Now, having done it first makes it easier because now, if we wanted to figure this out, what can x not equal to, well, we'd have to go through here and figure out what this is, and we would not, again, get the negative 1 because it would appear that x can be, or excuse me, a negative 1 would be here. The x minus 5, I guess, is the one that doesn't work. But anyway, you can end up losing one of these, and you'll see that later in the homework especially. So it's just safe to write down all three values. And when you get to your answer, rewrite it down here. And some of the students say, must I do it with every step that I do? I'm really not interested in being that kind of a taskmaster. In pure mathematics, you should, but if you figure it out up here, just remember that when you finally get down to the answer, maybe you have 3 or 4 steps to get to the answer, then just write it on your answer again, and that's fine. Yeah, I guess that's saying that the 5 is the value that you would lose. Composite functions. Composite functions are putting one function into another function. So if can be written in 2 ways. This f of g of x is how you say that. That's the composite function symbol. The book just simply uses it this way, as I recall. So either way, whenever you see this, whether it's in this course or another math course, it's a composite function. You put one function into another one. So now, if we're doing a composite function of f of g of x, then we put f of x into, or g of x into f of x. When you think about it, you always, when you're doing parenthesis, you always do what's inside the parenthesis first. So the first thing we do is put in g of x. G of x is inside the function f of x. So this f of g of x is equal to f of, and then you simply put the equation or the function g of x in here. Now you take this g of x in here, the 4x plus 5, and put this into f of x, since that's what's still out here. So when you're doing this, just think about this. You start first with what's inside, and then you work your way outside. So when you put 4x plus 5 into f of x up here, you're going to get 2 times x, which now we're putting in 4x plus 5 in place of x, and then subtracting 3 from the original g of x function. So it becomes 2 times the quantity 4x plus 5 minus 3. And again, that comes from up here. We put g of x in place of this x. Now, we do the math, so to speak, of the algebra. The 2 times 4x is 8x, the 2 times 5 is 10. The negative 3 is still there, of course, so we subtract 3, and we get 8x plus 7 is the composite function, f of g of x. Now, if the order is the opposite way, where it says it's g of f of x, well, it's not going to give you the same answer. It will be different, as you're doing it in a different order. Again, we start from the inside. The innermost is f of x. So we're going to, g of f of x is g of, now you put f of x in there. F of x is x minus 5. So now we're going to do a g of x minus 5. So you put x minus 5 into every x value in g of x. So when we do that, it's x squared. So you put the entire x minus 5 in place for x, and then you square it. So using the parenthesis is always helpful with this. It becomes x minus 5, the quantity squared. Minus 2, again, we're replacing x minus 5 with the x, and using the parenthesis is helpful. So negative 2 times x minus 5. And of course the plus 1 is still there because g of x ends with plus 1. Now we do the math, do the algebra. X minus 5 squared is x squared minus 10x plus 25. And you can think of x squared as x minus 5 times x minus 5. So it's going to be x squared, and then the middle term is minus 5, and the other term is also minus 5, so it's negative 10, and we put the x after it, and then we take the negative 5 times the negative 5 to get plus 25. Subtract, you distribute the 2, negative 2x, and plus 10, negative 2 times negative 5 is plus 10, and then we add the 1 as from g of x as from before. So when we're done with this, now we combine like terms. The negative 10x minus 2x is minus 12x. and plus 25 plus 10 plus 1 is 36. So we end up with x squared minus 12x plus 36. Now, working points of intersections. If you want to find a break-even point when you're working with something, a break-even point is the point at which the cost equals the revenue for a company. That's the point at which they start to make a profit. If they produce fewer units and they have more cost than revenue, they're losing money. At some point, cost equals revenue, and then as all companies want to do, you get to the point that your revenue is greater than your cost, so you start to make money. So the break-even point is, again, basically you're not making any profit, but you're also not having any losses. Total revenue is just sufficient to cover the cost. Now, in working with this specific company, it's a wireless company, so we need to know the break-even point. They're going to be receiving money from their customers for the internet service. That's their income, and then their cost is what it costs so that their customers can get the internet. So the break-even point is going to be in terms of customers. How many customers do they need to have to break even? Now, continuing with the problem, so your company assesses that monthly revenue, your income, is this revenue function, 32x minus 0.21x squared. And monthly costs are the cost function, 195 plus 12x. Now, if you get out into the business world, in larger companies, Fortune 500 companies and so on, and really large companies, you do see functions in terms of x and y, or revenue functions in terms of x and cost functions in terms of x. Smaller companies don't necessarily always figure this out, especially the smallest companies, mom and pop shops, so to speak, may not figure this out. But this is something that can be handy, and it's also something that you just need to know if you're going to go on for a master's in business. Now, the rest of the problem says where each x means 1,000 customers, and the revenue and cost is in thousands of euros. So this is a relatively large company. So if our answer comes out where our x, say, for example, it was 50, that would be 50,000 customers. And our revenue cost, if it came out to be 100, that would be 100,000 euros, not just 100 euros. So keep that in mind. It's important in the questions. Obviously, telling your supervisor that you made 100 euros last month versus 100,000 euros would not be a good thing to do. So always remember this kind of thing and apply it when you're finished with a problem. It's important. Now, what are the break-even points for this company? Well, we've already said that we have that the break-even point is when the revenue equals the cost. So if these are the two functions, the revenue function and cost function, when to break even, these have to have the same value. Or here's a picture. At what point do the two lines intersect with each other? Where do the lines cross? And as you can see, the red line is the function, the cost function, and the blue line is the revenue function. Now, as you can imagine, cost will go up rather consistently with this kind of company, but your revenue may not necessarily. There is at some point where even if you advertise for more customers, the number of new customers you get will not continue to go up, and as your cost gets too high, you start to lose customers because you're charging too much, so your customer base drops off. So in this particular problem, there's going to be two break-even points. Here when you're starting up, and up here when you're becoming too expensive for your customers to want to continue with you. Now, if this is the cost function and the revenue function is this curve function, as we know, profit is revenue minus cost. So if there's a profit, it's going to be the difference between these two. At this point, some number of thousands of subscribers, the cost is going to be this amount, and the revenue is going to be this amount. So the difference between these two are the profit. Up at this point, I don't know what this is yet. Let's just simply suppose it was 80,000 or 80,000 subscribers. The cost would be this cost, and your revenue is this much, so your profit would be only this much, smaller than this. So hopefully that makes sense. When you're doing this, you always compare it vertically, that your revenue and the cost is on the same X value that you have down at the bottom. So ideally, when this is the largest, that's the number of customers and income and cost, the greatest profit. That'll tell you where you should have the number of subscribers to get the greatest profit. And that would be your goal, not to go greater than that. But anyway, back to this problem. How to find these two? Well, we notice here that the cost and revenue functions, they're the same value, and here. So whenever the cost equals the revenue or the revenue equals the cost, then that is exactly where we need to do this. And in the formulas, we just simply say, oh, well, R of X equals C of X. They have the same value. So you set the the 32x minus 0.21x squared, you set that equal to the cost function, the 195 plus 12x. Then we see this, and now you just simply solve for x. So basically subtracting 32x from both sides leave us with 0 is equal to this 0.21x squared minus 20x plus 195, and we continue to solve. Now, working with this, we're not going to be able to factor this easily unless we use the discriminant and the quadratic equation to solve. And I'm assuming you know how to do that. If not, we can talk about that. But using the discriminant and the quadratic equation, you get an x to equal 11.03 and 84.21. Now again, you don't want to go to your supervisor and say, hey, our break-even point is when we have 11 customers and 84 customers, because that's not true. Remember, we said X was in thousands of subscribers. So that means it's 11,000 subscribers, or specifically 11,030 subscribers, because it's thousands, we move the decimal point 3 times, and at 84,210 subscribers. That would be what your boss wants to hear. Now, when we're working with factoring, in essence what we're doing is we're doing the FOIL method backwards. If we have an x squared plus something x plus something, you can look at it as the term with the x is two values added together, and the last term, that's just a number, is those two values multiplied together. Now, if you say, oh, this is more complex than what I want to learn, that's fine. If you are comfortable solving it with the discriminant or using the quadratic equation, it's okay. It just takes a lot longer. A lot of these things, especially ones you'll see in homework, are set up that you can do it much faster using this factoring method. It simply saves you time. You don't have to work with the square root, and you also don't have to. There's less chance of making small little mistakes because using the discriminant and the quadratic equation has a lot of steps to it. Now, in working with this, here are 4 problems that I'll step through. At whatever point you feel comfortable, you can pause the video and then see if you can solve it, and then resume the video to see if you solved it correctly. For the first one, we have x squared plus 7x plus 12. The concept of this is that it's easiest to start with the 12 in this case, the two numbers that are multiplied together. That's going to give us either 12 times 1, which equals 12, 6 times 2, which equals 12, or 4 times 3, which equals 12. There aren't any other factors of 12. So knowing that, then we add these numbers together. Now, one of them could be negative, they could both be negative. So we have to keep that in mind. The easy way to think of it is do them by sets of factors. The 12 times 1 is 12. Use that one first. If that, you take the 12 and the 1, if you add them or subtract them, again, one or both of them could be negative. So is there any way to add or subtract 12 and 1 that you get the 7 that's in the middle? You say, well, no, obviously, you're either going to get 11 or 13. It doesn't work. So you can quickly know that that's not correct. Then you can go to the 6 and 2. Is there any way to add or subtract 6 and 2 to get 7? Well, no, you're going to either get 4 or 8, and you can't do it. So you go to the 3 and the 4. Is there any way to add 3 and 4 together to get 7? Of course you can. So we're going to end up with 3 and 4. Now when we do this, excuse me, when we do this, we look at it and say, yes, it's the 3 and 4. So usually what I do is I'll come in and I'll make this, I'll set up the 2 parentheses and leave them empty inside with enough space that you can write inside the parenthesis. For example, to do it like x. And then I'll say, okay, the first terms, both of them have to be x, so I'll just fill them in. Now I figured out that it's 3 and 4. So I put in 3 or 4. And if I'm doing that, now I just need to figure out, are they plus or minus? The easy way to do that is that when multiplied together, they have to be positive. So that means that the 3 and the 4 either both have to be positive or they both have to be negative. And you know which one it is by looking at this plus 7. We have plus 7, the only way to add them together is to get them to be positive is if they're both positive. If they're both negative, you'd have negative 7x. So since they're positive, we just fill them in this way. And we get the x plus 3 and the x plus 4. Now, let's run through that again for the next one. Sometimes as you get comfortable with this, if you look at both of them together, it helps you figure it out. I'm using, again, the same factors just so we get familiar with this. You don't always have to start with the 12 and the 1, but I'm just doing it for 2 reasons. One is it's just good practice, and secondly, I also know that that's not going to be this one, so just stepping through it helps us to run through the process several times. Because after all, factors are, again, 1 times 12, 6 times 2, and 4 times 3. With the 1 times 12, there's no way you can add or subtract 12, or 1 and 12 to get negative 4. So that can't be it. The 6 and the 2, 6 times 2 is 12, but 6 and 2 you can get 4 with. So if we're working with this, then we probably want to start with our x's. And we've determined that 6 and 2 will do it because 6 minus 2, for example, is 4. So we're going to have 6, excuse my writing, it's a little hard with this mouse, and 2. Now, it's going to be negative 4. So how would it be negative? Well, the only way you can add these together and get negative is if the 6 is negative and the 2 is positive. Negative 6 plus 2 is negative 4. So it has to be negative. If we do it the other way, and make this positive 6 and minus 2, then we get plus 4. And that's not what it's asking for. So that's how we figure it out. And also, then we double check it. Negative 6 times positive 2 is a negative 12. And we see that it is indeed a negative sign here. So don't forget to double check that to make sure that you got the answer correct. So that is when we do this. Now, the next one, multiplied together is 12, added together is 13. Obviously, that will be 12 and 1. To get to the negative 13, well, one way that can happen is if both the 12 and the 1 are negative. Negative 12 minus 1. So becomes our answer. It becomes the x's, write the parentheses first, write the x's, fill in the 12 and the 1, and they both have to be negative. The negative, and then check the last term, negative 12 times negative 1 is plus 12. So you know you got it right. On the next one, this looks like, well, how do you do this? The formula doesn't work with anything having the x squared with a coefficient, but we notice that 3 is a factor of every term inside the original one. So factor the 3 out first. Remember, when you do factor, that you have to factor the 3 out of every term. So 3 divided by 3 is, of course, 1, or you don't have to write the 1, it's just x squared. 12x divided by 3 is going to be 4x. And negative 36 divided by 3 is negative 12. Now we can factor it. If we're going to do this, multiplied together is 12. So we have the same factors. And the ones that are, when you add them together, you're going to get 4 somehow, or add them or subtract, you get 4. That has to be the 6 and the 2. So you just kind of fill that in. Don't forget to bring the 3 down when you do this, because this is part of the equation, even though it's outside. If you're doing your profit function and you forget this, your profit's going to be a third of what it should be, so make sure it's there. So with the 6 and the 2, since this was positive 4, the 6, the bigger number has to have the positive sign of the 6 in order for it to be positive. The 6 minus 2 gives the positive 4. And then plus 6 minus 2 is going to be negative 12, and that's what we have up here. So we factored it, and we know that it's correct. So hopefully with the homework you can practice this till it feels comfortable. Again, you don't have to use it, but you can go through this rather quickly rather than going through once you're comfortable with it, rather than going through the entire discriminant or quadratic equation to figure it out. Now, there are some special cases when you're factoring, and that some of these, it's just faster to realize that when you see this kind of thing, that it's something squared. And one way you can go through and you can factor it to figure this out, or you can go through and use the discriminant in the quadratic equation. But if you can learn to recognize it, it saves you a lot of time, especially on tests. This last number, the 9, we know it's a perfect square, 3 times 3. And this, especially the negative 6, if this was 3, 3 plus 3 is 6. So it obviously has to be x and a 3 for these terms. But since this is positive, they both have to be positive or negative. And since this is negative, then they both have to be negative. So if you can get adept at recognizing the entire equation, when you have this set up, you have a perfect square and then that perfect square added to itself, then you can quickly just jump to this stage if you know it. Some students like to memorize it, but as you get familiar with it, you start to see it pretty quick. If you're using the factoring method, the worst you do is do the in-between step and you realize, oh, it's just x minus 3 squared. It wasn't so bad. Now this, sometimes say this is looking at these are both perfect squares. 5 times 5 is 25, and x times x is x squared. So whenever you have that kind of thing happening, and there's no x as an in-between term, it's just x squared minus 25 or x squared minus 36 kind of thing, that's always going to fall into this form. You can factor it to here pretty easily, but if it's in this form and you know it's going to be in this form, then it's simply you take the square root of this and the square root of this, so you get the x and the 5, and the sign in between them has to be opposite, because using the FOIL, the outer is going to give us minus 5x, and the inner is going to give us plus 5x. That's the only way to get to 0x so that that term disappears. So if you see this, just memorizing that just makes it fast. You don't have to waste any extra time. When you're doing this problem, you may want to actually factor out the negative and put it into the order that you're accustomed to. Now, a lot of students don't think about this, but having a negative x squared, that's the same thing as negative 1x squared. And you can factor out the negative 1. Just remember, when you're doing this, to also factor the negative 1 out of the minus 8x and the positive 20. That's why the signs change. Or just think about it as if you pull a negative sign out, all of the signs from the original one have to change. And then we factor this. It can be 20 and 1, or 20 times 1, but there's no way to add or subtract 20 and 1 to get 8. So you can check 10 and 2. That works. 10 times 2 is 20, and 10 minus 2 is 8. So we know it's going to factor into that, and then just figure out the appropriate signs. Since the middle term is plus 8, the plus has to go with a larger number. And then the minus goes with the other one because you have to subtract to get 8. Also, whenever you see this kind of thing, if there's an x in each term, factor that out first. So it becomes x times x squared, and then 3x minus 18. Now you can factor it. 18 and 1, but there's no way 18 and 1 is going to add or subtract to get 3. 9 and 2. But that doesn't work because there's no way that 9 and 2, when you add or subtract them, you get 3. But then you have also 6 and 3. Well, the difference between 6 and 3 is 3. So we know we have those factors rather quick. And just figure out that since the plus 3x is positive, the positive has to go with the bigger number, so it ends up being positive. And then double check. Plus times a minus is a minus. This one's a little bit strange. You probably first see that there's an x in each of these, and yes, you factor out the x. And now you say, but Greg, it's not a perfect square, like we did up here with the x squared minus 25. I think you'll see this in the homework, and the back of the book will give you the answer like this. One way to try and shortcut this is to say, well, if I take the square root of x squared, it's going to be x. Since there's no middle term, it's just a plus and a minus. And I can't take the square root of 10, but the square root of 10 times the square root of 10 is 10. So I won't do this on an exam or anything like that, but the homework you will see in the homework. Don't let that throw you. That's how they got this. It's using the same concept as we did up here by taking the square root of both of these. And the square root of 10 is simply the square root of 10. So it's a little strange, but it's what the book did. Now when solving, as I said, factoring can make it easier to solve for x. If we have this equation and we want to factor it, we can factor it down to 6 and 2. Two things multiplied together, that equals 12, and when you add or subtract them, you get 4. Well, obviously 6 and 2 works with that. Now the next step with this is just recognizing that this is some value and this is another value. So if you have a value times a value and equals 0, well obviously either one of the values or both of the values has to equal 0. Something times 0 is equal to 0. We don't know which one it is, so what we do is we set both of them equal to 0 and do it separately. That the x minus 6 is equal to 0, because that would give us 0 in the equation above, or the x plus 2 is equal to 0, and that would tell us that the second term is 0, so the whole thing is equal to 0. So now this becomes simple to solve. Start with the first one, or you can work on them simultaneously if you wish. Some students like to do the x minus 6 and get to that answer. If it's longer, this is rather short, so it's just one step. Obviously, x either is 6 or it is negative 2. In either of these cases, x is equal to 0. So to solving for x, we know that x is equal to 6 or it's negative 2. Now, as you get accustomed with factoring like this, kind of think of it as the reverse FOIL method. Obviously, this was a lot easier than using the discriminant and the quadratic equation to solve this. Some of the stuff you can just do in your head, write down your steps as you go. But again, it's up to you what you want to use. Moving on to exponents. These are extremely important. Do understand this. We're going to use it throughout the course. And because of that, if you don't get it now, it's hard to get a good grade in the course. So learn it now when you have time. Anytime you have some number raised to a power, Well, it's going to be that number times itself, in this case n times, however many times the exponent is. So it's going to be times itself n times. Now, one of the other laws to remember is that anything to the 0 power is always equal to 1. This comes in handy in calculus frequently. Any number, doesn't matter if it's 1 or 10 million or negative 336,000, if it's raised to the 0 power, it doesn't matter if it's positive or negative, it's simply, the answer is going to be 1. When you have the square root of something, whatever is inside of it, if you can break it down into some number squared, well, that when you take the square root of it, it's simply going to give you the original number. 6 times 6 would be 6 squared, and that's 36. And we know that the square root of 36 is 6. So that can be a quick thing to remember. Whatever you have inside of here, if it's squared, you can simply bring out just the b part of it. So if it was 36,872 squared, you don't have to do the math. You just know that it's going to be 36,872 for the answer. Whenever you see this, hopefully you have seen this before, but if not, this is the cubed root. So it's going to be, the cubed root means you have to, instead of pulling out, for example, the square root of 2 is 4, the cubed root, the third root of 8 is going to be 2. 2 to the third is 8, and because it's 2 times 2 times 2, so if you're taking the third root of 2 to the third, then it's simply going to be 2 out here. But you have to have this number multiplied by itself 3 times in order to do that. So when it's not written there, it just means it has to be multiplied by itself twice. If it's a 3, it's multiplied by itself 3 times. If it's a 4, it's multiplied by itself 4 times. So when you see that, don't let that throw you. It's just an extra time, or however many times it says. If it's a 7th root, it's going to be the number times itself 7 times to be able to pull it out. When you see this, remember, every time you have a group of 3 of these, you can pull out one of them. So you can think of this as b times b times b. Well, then I can pull out because of this, and I get b. So that comes to the outside here. Now, this is b times itself 5 times. So if I pull 3 of them out, I'm left with 2 of them. So that's why we get the b squared at that point. So whenever you're working with this, you can kind of think of it as, I'm going to group together 3 b's, and for every 3 b's that I'm multiplying together, I can pull one of them out. So I pull out 3 of them. 5 minus 3 leaves you with 2. Now, I'm going to introduce this rule here using this, that if you have the y root, I mean, the y means it could be any number. It could be the square root, it could be the third root, it could be the 4th root, 5th root, and so on. And then you have b to some number. This rule means that written this way, b to the x, that is the top number. And the y is what goes with the root. So these two are equal to each other. The y root of b to the x is the same thing as b to the power of x divided by y. So this works backwards and forwards. If you have b raised to the power of x over y, that equals the y root of b to the x. So again, remember that the y always is the bottom number. The denominator is always associated with the root. And the top number, the numerator, is always, that sticks with the b and stays and goes inside of the y root, or the square root, or whatever it may be. So if we had b to the 1/2, again, the numerator stays with the b, and the 2 goes to the outside of the root. So it's the square root of b to the first. Well, b to the first is just b. So it becomes the square root of b. You don't have to write the 2. If there's nothing there, people always assume that it's the square root. B to the 1/3, again, the 1 stays with the b, and then you have the root sign, and since it's 3, it's the third root. And of course, we don't have to write the 1, so it's simply the third root of b. If you have b to the 5/8, well, again, the b to the 5th power, the numerator stays with the b, and then the 8, the denominator, goes with the root. So it's the 8th root of b to the 5th. If you have b to the 7/4, it's going to be b to the 7th, and then the root is the 4th root. Hopefully this is making sense. Now, with this particular one, b times itself 4 times. Every time that occurs, you can take one of them out and put it on the outside. So b to the 4th you take out as b, and so hence you get the b outside here. It's still the 4th root of however many b's are left. Well, if there were 7 inside of here and you took out 4 of them, well, then there's 3 left. So 7 minus 4 is 3, kind of thing. Just a few more for review. This is, excuse me, not for review. This is going the opposite way. If you have the 5th root of x squared, what's the fraction going to be if you're going to try and switch this the other way? Well, again, whatever exponent is with the x, that is the numerator. So that's going to be the 2. And the denominator is the root. So the root is going to, or the denominator is going to be the 5th root, or the 5. So it becomes x to the 2/5. Using that same kind of thing, if we have the 7th root of x to the 4th, the 4 stays with the x, so that's in the numerator, and the denominator is the root, so it becomes 4/7. Now this, again, this is something that's just helpful to remember. We're going to use this. Another important law of exponents is that whenever you have a negative exponent, it just means that you can think of it as taking this b and putting it over 1, and the negative means that you flip it over, so it becomes 1/b to the n. That's just something to memorize, to become familiar with. It makes your work a lot easier. How this actually works is that it's b to the negative n, so we can flip it over, or write it this way, as I showed over there, to the negative n. Well, the negative means that you flip it over, and it becomes 1/b to the n power. Now the n gets applied everywhere, but 1, however many times you multiply it by itself, is going to be equal to 1, and you get b to the n in the denominator. So that's the little math proof, so to speak, that shows how this actually works. So if you have x to the negative 2, it simply means that it's 1/x squared. Again, the exponent, the only thing that happens to it when you flip it over is that you lose the negative sign. It becomes positive. If you have x to the minus 6th, it becomes 1/x to the 6th. If you have x to the negative 5/9, again, it becomes 1/, now you put everything there, x to the 5/9. And if you want to convert back, say you actually have to solve something with this, the 5/9 means that it's going to be the 9th root, because that was the denominator. The 9th root of x to the 5th, again, the numerator, the 5, stays with the x all of the time. X to the 1/4, if this is going backwards, and sometimes when we're solving problems, it's easier to solve them with exponents. And 1/x to the 4th, well, that was going to be x to the what? Well, we have inverted it, so it's 1/x. When you invert it, it becomes x. And then you have to put in the negative sign because it's not there. So the negative means that we are inverting it to the -4. Going the other way, we're more accustomed with. X to the -4 means that we invert it and keep the 4 with the x, just like we did over here. But now we're going backwards. All right, this is the first one here. x squared, if we wanted to make the exponent negative, we would invert the 1 over x and keep the 2 there and just put the negative in front of the 2. This is a little bit more confusing, but hopefully you can see it works forwards and backwards. X to the 1/7, if we wanted to put it in terms of x and not as 1 over x, we have to negate the exponent, which means make it negative. So it's going to be flipping it over gives us, well, x over 1, if you want to think of it that way. You can actually write it, it's not a problem. And put in the negative because you've inverted it, and then keep the exponent the same, 7. But of course it negates the exponent in the long run. If we had this, we would work with, we want to convert it first to the exponential form. We don't need the 8th root of x squared, we need it in terms of x raised to some power. The 3 is the denominator, the 8, since it's the root, is the denominator, the 3 is the numerator, excuse me. Now we want to invert this, so it becomes x. When we invert 1 over x, it becomes x, and we negate the exponent that was there. So it becomes negative 3/8, x to the negative 3/8. So this can be helpful. Other laws that are in your book as well are these, and these are ones that I'm assuming that you already know or we just went over recently. When you're working with this, you have b to the r times b to the s, and have the same base here. You can add exponents. We just covered the second one. The third one is kind of the opposite of number 1. If you have the same base but different exponents, b to the r divided by b to the s, you simply subtract exponents. If you use law 2 in between, b to the r times, well, it'd be 1 over b to the s. And if we use this law to negate it, it becomes b to the minus s. Then we can use this first law and say that it becomes b to the r plus minus s, which is r minus s. So that's where that actually comes from. But an easy thing to remember is when you're dividing, you have the same base but different exponents, you just subtract. This one's good to remember, that when you have something to a power and the whole thing is raised to a power, then you're multiplying the exponents together. Over here we're adding because we're not taking b to the r and raising it to another power. It's simply 2 numbers times itself. This is a number raised to a power, and that answer is raised to another power. So we get b to the r times s. Whenever you have something inside of a parenthesis that is raised to a power, you have to raise each term. Even if there was a 3 out in front of this, it would be 3r a to the r, or excuse me, 3 to the r, a to the r, and b to the r. And the same thing works when you're dividing. Whenever it's a parenthesis and it's raised to a power, every term inside. So it becomes a to the r divided by b to the r. Now, in practicing that, when we're working with this, we have the same base. It's still, everything is 2. 2 to the 1/2 times 2 to the 1/3. We can add exponents inside the parenthesis first. So it becomes 2 to the 1/2 plus 3, plus 1/3. Now, finding a common denominator and adding them together, just like we've done since elementary school, when we do that, we end up with 2 to the 5/6. Now, because it's a number raised to a power, that is, the whole thing is raised to a power, it becomes like number 4 of the laws up top. You multiply the exponents together. So it becomes 2 to the 5/6 times 6 over 1. And you can think of that as 30 over 6, which when you take 30 and divide it by 6, you get 5. Or you can say, well, a little shortcut here, the 6 and the 6 here are the same, so I'm going to divide this by 6 and divide this by 6. They cancel, they factor each other out, and you're left with 2 to the 5th. So some of the stuff you can kind of do in your head if you're just familiar with the laws. For example, if you wanted to work with, if you solved this problem in the book, they would give you this answer because this is equal to this. So sometimes converting this into exponents makes it a lot easier. Otherwise, how do you do this without a calculator? Well, this you can do in your head. The square root of 2 becomes 2 to the 1/2. That's 2 to the first over the square root of 2. And this becomes 2 to the 1/3. 2 to the first divided by the 3. It's 2 to the 1/3. So now it's in a form that we can manipulate it and get 32 as the answer, versus it would be really difficult to do this way. So sometimes using these laws makes things simple that would otherwise be complex. Another example, convert the square root of 5 that's in the denominator to exponents. Now it's simple. 5 to the 2/3 divided by 5 to the 1/2. We look at the laws above and we say, oh, it's the same base, it's the same 5. So now we simply subtract. So 3/2 minus 1/2 is 2 over 2. Well, 2 over 2 is 1, right? So it becomes 5 to the first, which is, of course, equal to 5. Working with this one, if we have, this would be hard to find an answer for. But if we convert it to exponents, it makes it relatively easy. So the square root of x becomes x to the 1/2. The square root of x to the 3rd becomes x to the 3 over 2. And 3 times the square root of x becomes 3 times x to the 1/2. Review the earlier sections if you're not quite sure how I did that, but hopefully it makes sense. Now, when we do this, the x to the 1/2, we distribute that. We multiply it by every term inside the parenthesis. And when you're multiplying by the same base, you add exponents. So it becomes x to the 1/2 times x to the 3/2. And of course, that means, since it's the same base, you can add them together. So it becomes x to the 1/2 plus 3/2. The x to the 1/2 times the plus 3x to the 1/2. Again, we can since it's the same base, we can add the exponents. The 3 we don't do anything with because it's just there. It has nothing to do with the x, so it simply stays as 3. So it's 3 times x to the 1/2 plus 1/2. Well, of course, that's 1 to make it a little bit easier. But the next step, if we start back with the x to the 1/2 plus x to the 3/2 is x to the 4 over 2. And already said that becomes 3x to the 2 over 2. Do the normal simplification. 4 divided by 2 is 2. So that x, the first one, becomes x squared. And of course, the last x just becomes x to the first, which is just x. So the 3 was along with it since we're multiplying. So the answer becomes x squared plus 3x. So again, a lot easier to do than trying to figure it out without using the exponents. Now, here's an example that we probably might find in the book. A car rental company charges 20 euros per day and 22 euros per kilometer to rent a compact car. Suppose a car is rented for 1 day and express the total revenue expense as a function of the number of kilometers driven. Well, that seems kind of rough, but let's break it down. We're going to find a function, right? So f of x is equal to. Now, if the car is rented for 1 day, we want to find the total expenses. Well, how much is it going to be? Well, the car rental, regardless of whether it's 1 day or 20 days, is 20 euros per day. And it is 22 euros per kilometer. Since we're only doing it for 1 day, we know that the cost is going to be 20 euros, since it's 20 euros per day, plus how far you drive it. We don't know how far we're going to drive it, so we just let that be x. So again, we can look at this as it's 20 euros for that first day. And we're going to add to it 0.22 times the number of kilometers that we drive. Well, let that be x, and it becomes 0.22x. Now, we can look at it, we can leave the answer like we did originally, or if we wish, put it into the general form where you always have the x's in descending exponential order. We're used to seeing the x's come first, in other words, so we can switch it to that. So this is simply the function. When we're doing it for 1 day, it's simply going to be the 20 liters, and x times the 22 euros per kilometer, where x is the kilometers, is the answer. The homework for this section is, again, to review these sections. Just be familiar with it. You can see all of the problems from the different sections. If it's something that you're familiar with, you don't have to do all of them, but I would recommend that you're able to do these kind of things, as we'll, again, see them later, this kind of work later. For the section 0.6, in numbers 33 through 44 all, it says refer to figure 9 on table 1. I believe it's on page 46 for help. It just makes it easier in trying to figure the problem out. That's what it's referring to.